Assalamualaikum warahmatullahi wabarakatuh. So, uh, my name is Muhammad Afiq and I will present about the production of aniline in the correction and the PFD, the new PFD one. Okay, so my group is group 5, which is Alif Kami, Murad Encik Ahmad, and Kancana Ravindran. Okay, so this is the old one for the process degradation, and we have done some the correction. Okay, first, this is the vaporizer. So the vaporizer were eliminated due to the Aspen tool doesn't accommodate us for the vaporizer tool. Okay, and next, the reactor outlet, the temperature reactor outlet is changed into 1377 degrees Celsius for convenient reaction. So at first, for the old one, we used 4 to 7 degrees Celsius, but the new one, we when we running into the Aspen ICs, so it produced the 1377 degrees Celsius for better and convenient reaction. And then at this condenser, we change into the separator instead we using the condenser. And then at the first distillation column, for the old one, we produce aniline and water at top product, but nitrobenzene in the bottom product. But for the new one, we only produce water at the top product, and nitrobenzene and aniline goes down into the bottom product. And then for the second distillation column, we separate aniline at the top product and nitrobenzene into the bottom product. So, and then some streams number will change. Okay, next, moving on into the new one. So there's some stream number will change, and then at the first distillation column, the water is separated first at the top product, and then we followed by aniline and nitrobenzene into the bottom product. And moving on into the second distillation column, aniline is still remain as the main product at the top product of the second distillation column, and then the nitrobenzene will flow out into the bottom product. But in the old one, we recycled the nitrobenzene, but in the new one, we only flow out the nitrobenzene from the process for the objective to sales to the market. Okay, so this is the description we have been throughout all the plant design project. So at first, we do some manual calculation and assume some operation condition for unit operation. And then we simulate using the Aspen high Cs. And then we identify the problems and we do and done the sum correction. And then the aniline is remain as the main production, and it is the priority product. And then when we running the process into the Aspen IC simulation, there's some error is due to the inconsistency in the Aspen simulation, but overall it has only below 15% of the error. And lastly, we moving on into the heat integration.
Hi everyone, I am Nurul Ain and I will be presenting task 3 for heat integration. First of all, from this stream summary, it can be observed there are 4 cold and 2 hot streams. The value for the mass flow rate and the enthalpy of each streams were obtained from the Aspen stream summary. So the CP values can be obtained using the equation CP equals to delta H over F delta T. The delta T mean is assumed to be 10 degrees C, which then shifted temperature for each supply and target temperature were obtained. Next, by plotting the shifted temperature in PTA table, other values such as summation of FCP and cumulative delta H also can be obtained. By determining the pinch point, the pinch temperature were also obtained. From this PTA table, the pinch temperature for hot and cold stream were found to be 1376 degree and 1366 degree, while the percentage of hot and cold utility reductions were found to be 100% and 24.9%. Next, the grid diagram was drawn in order to determine the heat transfer between the hot and cold stream by heat exchangers. From the grid diagram, it can be concluded that for this process, there will be 5 heat exchangers and 1 cold utility, which is cooler, to be used. Here we can see that HE3 violates the rule for below the region because the FCP hot stream H1 is smaller than FCP cold stream C1. But in order to minimize any heat waste, the heat from the stream H1 was used to heat the cold stream C1. The core utility cooler, which have same work duty as QC mean, is used to cool down the remaining heat in the stream H1. Lastly, the PFD after implementing the heat integration was withdrawn. Here we can see the hot stream H1. The hot stream H1, which is the stream 8 plus, was chosen as the static stream, and the other hot and cold stream is considered as the moving stream. That's all from me. Thank you.
Hello everyone, I'm Kanchana. Today I'm going to present about the process optimization. In this project we used two distillation column and the second distillation column was choose to optimize, and this distillation column is used to separate aniline and nitrobenzene. Therefore the objective is to maximize the purity of aniline at distillation column 2. The optimum condition was evaluated from reflux ratio, reboiler duty, condenser duty, and purity of aniline. Therefore, the decision variable is the reflux ratio. The possible constraint is inequality constraint, where the reflux ratio was set at this range: 1.775 as the minimum value and 2.13 as the maximum reflux ratio. From the data obtained, the relationship between the duty and reflex ratio and also the relationship between the purity and reflex ratio was this. As you can see, the duty of the condenser and reboiler was increased with the reflex ratio, while for this graph, the purity of aniline was increased with the reflex ratio, but after at certain point, the purity of aniline is almost same. Therefore, the optimum reflux ratio was selected is 1.952. This is because at this point the purity is almost reached 100 and the condenser and reboiler duty is low.
So next I'm going to proceed with the equipment sizing, but first of all I'm really sorry because I cannot include myself in this video because there are some technical problem with my laptop. So this equipment sizing is one of the fundamental design for a plant which is directly affect the profitability and economic feasibility of the plant. For equipment sizing design, calculation are performed based on the fundamental design knowledge and some assumption will be made on the equipment specification. So this is the equipment involved in our plant design for the production of aniline, which is the include 3 heater, 2 cooler, 1 condenser, 1 compressor, 1 mixer, 1 pump, 1 reactor, and 2 distillation column. So for the cost, next is the equipment costing. This is the equipment purchasing cost and bare material cost are estimated based on the sales factor of each equipment. Each equipment has its own equation for costing calculation in order to determine free of board FOB purchase cost. So based on this table, this is the all the list of our equipment purchase price that include all the equipment. So that's all from me. Thank you.
Let's proceed with the capital investment. In this project, the third method, which is a preliminary estimate method, was chosen to calculate the total capital investment, and the equation used is this one. The total capital investment was calculated by sum of the working capital and the total permanent investment. The bare module cost was calculated by multiply the bare module factor with the equipment cost. And in this project, several estimation was made where the cost of offsite facilities, the working capital, and also we estimate it is not a cross route plan. By calculating all the value and insert in the equation, the total capital investment obtained is $16,238,591. That's all from us. Thank you.